My project this year has been sort of at the interface of philosophy of mathematics and theoretical computer science, in particular computational complexity theory and algorithms, again, the subject of Alberto's A&R project. And so Alberto and I both come from closely related formations, let's say, in logic, sort of at the boundary of logic, and philosophy of mathematics, in particular proof theory and computability theory. And so we, in some sense or another, think of ourselves as sort of intellectual custodians of the what we might start calling traditional notion of algorithm and also computation. Roughly, in our sense, an algorithm being an effective or finitary mathematical procedure for solving a definite problem, such as computing multiplication or greatest common divisor, or deciding a mathematical property like primality, and then a computation being something like the trace or intermediate calculations, the bookwork that one goes through in carrying out such a procedure. And from our perspective, this is one of the most ancient notions of mathematics, going all the way back to the beginning of various classical traditions, but then becomes an object of mathematical reflection itself, starting maybe in the 1920s in mathematical logic, which then gives rise to the question whether all mathematical problems are solvable by an algorithm. So what I'm now going to do is, so the slide is projecting correctly. We're going to talk our way around this diagram very quickly as a sort of clock to sort of attempt to put in place the various questions and topics that we wish to highlight today. In other words, attempting to potentially build a bridge or point out various bridges that might be built to some of our traditional interests, and then developments in other areas, in particular in the social sciences, law, and ethics. So I already commenced with that. So we start out in the 1920s with the question whether all mathematical problems are effectively decidable by algorithms. That gives rise to the subject known as computability theory, which gives us notions such as recursive function, Turing machine, effectively computable function, etc. Starting, as I'm sure all of you know, sometime around the beginning of the 1960s, computer science comes into existence as an independently recognized discipline, and then starts to ask more refined questions about algorithmic solvability or decidability, in particular, how efficiently you can solve various problems with algorithms. This gives rise to the subjects known as algorithmic analysis and computational complexity theory, and the well-known hierarchies studied therein, and also maybe as just advertising, the vaunted P versus NP problem, which was actually the subject of my fellowship this year. But then, of course, computer science has not just this theoretical aspect related in many ways to our tradition in mathematical logic, but also an applied aspect. And perhaps one way of bridging that is the early work in artificial intelligence on subjects such as planning, search, knowledge representation, expert systems, Bayesian networks. But these are all now considered maybe even old-fashioned methods in AI, and we now, of course, live in the era of statistical-based methods such as machine learning and neural networks. And then, of course, what we really read about in the newspaper, systems like ChatGPT or Bard, large language models based on various sophisticated kinds of recurrent neural networks or so-called transformers. And then, of course, we're getting all of the questions in the media that one can hardly avoid about questions such as explanatoriness, safety, opacity, etc. So how do we, from our admittedly classical formation, transition to being interested in questions, say, in social science? Well, from our perspective, there's a natural point of contact that really is just a very immediate intellectual segue in the form of social choice theory. And there are two of our talks this afternoon are going to be on this subject. So this is the subject that you might actually trace all the way back, especially in France, to Condorcet, the Condorcet voting paradox, the possibility of certain cycles arising in voters' preferences, and then the question of what it means to have a fair or adequate voting system. But then as an academic subject, this really gets going in the early 1950s with the work of Kenneth Arrow, who coins the term social choice theory, and then proves his famous impossibility theorem about a voting system that satisfies natural adequacy conditions. We'll have something more about that later today. But then this, maybe in the maybe 1990s, gives rise to the subject of computational social choice, the question of whether, for instance, it's possible to design voting mechanisms which are, say, resistant to strategic voting or manipulation, or at least resistant to efficient ways, or resistant to ways that that actually somebody could carry out in practice of manipulating them. But anyway, social choice theory, naturally, Arrow was an economist, overlaps with economics, and then questions, for instance, about the efficiency of finding equilibria in games. And of course, social science or social choice theory was originally directed at questions that really arose from political science about the possibility of fair or democratic voting mechanisms, and also questions about fair division of goods. So this moves us perhaps to 6 or 7 p.m. In the clock, and now we transition to a few words that Alberto is going to say about law and ethics.
Thank you, Walter. I will add just a couple of words, not to be too long. Because Walter was tracing, so if we go clockwise in this reading of the slides, well, we find also a rather traditional connection between logic and computational methods coming from logic and law, something that exists since even Leibniz, but that has been developed especially in the 70s, is the idea of automatizing legal reasoning by using some formal methods coming from logic, plus some computational methods in the traditional sense that Walter was speaking of. But law is interested also in algorithms or computation as an object of investigation, and not only as tools in order to, let's say, formalize logical reasoning, but as proper object of study. And in this case, they don't just limit it. So the research in digital law does not just look at algorithms in this traditional fashion, but also it looks at them through the techniques that we use in machine learning, deep learning, and this, let's say, new artificial intelligence, AI. They look also something that interests us a lot, the relation between this system, algorithmic system, let's say, in general, and how the agent use them, and the interaction between an agent and these algorithmic systems. And because this interaction brings up, epistemic aspects, like, for instance, the problem of explicability, of understanding what an algorithm does, but also legal aspects, like the problem of responsibility. For instance, when you use a certain algorithmic method system in order to, take some decision, who is taking this decision? Who is responsible of that? These are questions that are arising, and that brings also questions towards the areas of ethics. And this is one example, but another example is, for instance, the question of privacy. When you use these methods, you exploiting a lot of data, personal data, how could you preserve privacy on them? And there are, again, the use of mathematical and formal methods for studying these things. For instance, differential privacy, all this stuff. I don't think that today we will speak of that, but these are things in the area. So. And this makes, I think, the round closer. So I think we are on time to start our workshop.